Hello, myself Vipul Bajaj from EC branch. I have been allotted lecture 13 for AA230 video assignment and my topic is continuous random variable. So let's start our question. We are given the cumulative distribution function f of x of the lifetime of a battery in tens of hours and it is described by the random variable x. It is 0 for x less than 1. For the subinterval x1 to 1.5 it is 7 by 10 into 4x square minus x minus 3, and for x greater than 1.5 it is 1. So we have to solve 4 parts. For the first part we have to find the median of x, giving the answer to 3 significant figures. Next we have to find the probability density function of random variable x. For part C we have to find the probability of x greater or equal 1.1. Then it is said that a camping lantern runs on 3 batteries, all of which must be working. 3 new batteries are put into the lantern. So we have to find the probability that the lantern will still be working after 11 hours. The solution is as follows. To calculate median, which is a point which divides any distribution into two equal halves, we put f of x equal to 1 by 2 because it is the cumulative distribution function that describes the distribution of random variables. We put its value in the subinterval of 1 to 1.5, that is the quadratic polynomial, because for other subintervals uh, we have the values as 0 and 1 that can't be equal to 1 by 2. So further we multiply both sides by 10, and solving these equations we get the final quadratic equation as 28x square minus 7x minus 26 equal to 0. Now to find x we use a quadratic formula. Putting the values of a, b and c, we get x as 1.09 and minus 0.84. Obviously the negative one is not valid because the cumulative distribution function is 0 for all x negative. Hence, our median is x equal 1.09 up to 3 significant figures. For probability density function or f of x in part B, we know that the cumulative distribution function at any x is equal to the integral of probability density function from minus infinity to x, or we can say that the probability density function is equal to the derivative of cumulative distribution function. So in the subintervals of x less than 1 and x greater than 1.5, f dash is 0 because f is constant there, and for the subinterval of x 1 to 1.5, we take the derivative of this quadratic polynomial and we get our f dash x is equal to 7 by 10 into 8x minus 1. So finally we have calculated the PDF of random variable x over all the subintervals as shown here. In part C, for probability of x greater or equal 1.1, we can write it as 1 minus probability of x less than equal 1.1, using the property that total probability over the complete range of any function is equal to 1. That is, integral of minus infinity to infinity f of x dx equal to 1. Further we can write it as 1 minus big F of 1.1 using the formula that cumulative distributive function at any a is equal to probability of x less than equal to a. So after that, putting the value 1.1 in the quadratic polynomial, because 1.1 lies in the subinterval of 1 to 1.5. So we are using that quadratic polynomial, and further solving this equation we get the final probability as 0.482. For the last part, for the probability of lantern working after 11 hours, we want all the 3 batteries running And for that we want the probability of x greater or equal 1.1 for all three batteries. Here we have taken x greater or equal 1.1 because the lifetime x is given in tens of hours. So for condition time greater or equal 11 hours to be satisfied, we took this. Now using the formula of total probability of three independent events, we multiply each of the events probability, that is probability of x greater or equal 1.1 whole to the power 3, and putting the probability value as 0.482, we get our final probability as 0.111. That is, there is 11.1% chance of lantern working after 11 hours. So that completes our question. Thank you.